All right, let's get right into it. Today, we are going completely under the hood of an AI that can automatically write an entire business proposal. Yeah, I know, it sounds like something straight out of science fiction, but we're going to break down the exact serverless architecture that makes it all happen. So think about this for a second. Could an AI really write your next business proposal? For a lot of us, that still feels like a huge leap. But you know what? The technology isn't just on the horizon, it is here, right now. And in this explainer, we're going to deconstruct exactly how a system like this is built piece by piece. So, what's the magic trick here? Well, it's a technique called retrieval augmented generation, or RAG for short. The idea is actually pretty simple, but it's incredibly powerful. First, the AI retrieves. It goes and grabs all the relevant info from a secure private library of documents. Then, armed with all that context, it generates a brand new intelligent response. See, it's not just making stuff up out of thin air. It's learning from your data first. Okay, so here's the game plan for our guided tour. We're going to start with the big picture, the 30,000-foot view. Then we'll walk right through the system's front door, meet its brains and brawn, check out its digital memory, and finally, we'll trace the entire journey of a document from upload to final output. So, let's start with the big picture. At its very core, this system is an absolute automation powerhouse. It uses a whole suite of interconnected AWS services to tackle one of the most tedious, time-consuming business tasks out there, responding to things like requests for proposals, or RFPs. It basically eats them, understands them, and then spits out a detailed, super relevant response. So, first things first, how does a user actually use this thing? Let's start at what we'll call the front door. These are all the components that handle how people and data get into the system in the first place. Four key services are basically managing the entrance. You've got CloudFront, which acts like a global delivery network, making sure the web app loads super fast no matter where you are. The web app itself is, the main interface. Cognito is kind of like the digital bouncer, handling all the secure login stuff. And then the API gateway is the receptionist, directing every single request to exactly the right place. And it's really important to get the web app's role here. It's not just some simple website. It is the user's command center. This is the spot where they upload their RFPs, they kick off the entire AI process, and of course, it's where they see the finished proposal at the end of it all. Now, this part is pretty clever. The system uses two different types of API gateways. The REST API is for direct commands, like when you click an upload button. But the WebSocket API, that's for a continuous, live conversation. It pushes real-time updates back to you, like, hey, your document is ready, without you ever having to hit that refresh button. All right, we're in the door. Now let's meet the real stars of the show, the core components that do all the thinking and the heavy lifting. This is the system's control center and its factory, all rolled into one. We've got four heavy hitters here. AWS Lambda functions handle all the quick, smart backend logic. Step Functions is like the project manager, telling everyone what to do and when. ECS Fargate provides the muscle for the really heavy-duty jobs. And finally, Bedrock Claude, that's our AI expert, the one actually generating all the text. And this is absolutely crucial to understand. Step Functions doesn't really do the work itself. It orchestrates everything. It's the conductor of the whole symphony. It tells the lambdas when to run, it triggers the heavy processing in ECS, it manages how data flows from one step to the next, and it even handles errors if something goes sideways. Now, some jobs, like parsing a massive 200-page PDF file, are just way too big for a quick little Lambda function. And that's exactly where ECS Fargate comes in. It's the system's heavy machinery, a serverless compute engine that can spin up to handle these super intensive, long-running jobs, and then poof, spin right back down to zero. And this is why serverless is so powerful here. You only pay for that heavy-duty processing for the exact seconds you use it. It's incredibly cost-effective. Of course, all this data that's being created needs a place to live. And that brings us to the system's digital memory. It's got a library for quick access and archives for long-term storage. We've got four really distinct types of storage here. Amazon S3 acts as this universal file cabinet for all the raw documents. Secrets Manager is a secure vault for anything sensitive, like API keys. And then we have two different databases that serve very, very different purposes. And this comparison is just brilliant because it really gets to the heart of the matter. The OpenSearch database doesn't store the words of a document, it stores the document's meaning. It does that by converting concepts into these numerical fingerprints called vectors. This is what lets the AI search for related ideas, not just keywords. The Postgres database, on the other hand, is your traditional logbook. It stores operational data. Who did what, when, what's the status? So one stores meaning, the other stores facts. Okay, we've met all the players. Now for the main event. Let's follow a single request for proposal on its complete journey, all the way through this entire system we've just mapped out. So it all starts when a user logs in through Cognito and uploads an RFP in the web app. The API gateway catches that request and tells a Lambda function to go store that raw file in an S3 bucket. That single action triggers our conductor, step functions, which officially kicks off the main workflow, starting with those heavy processing tasks in ECS Fargate. ECS then breaks the document down, creating those numerical fingerprints, the vector embeddings we just talked about. Now, this is the key moment where the AI, Bedrock Claude, steps in to analyze the RFP and generate the new content. Those vectors, the document's meaning, get stored in the open search library for future reference. Meanwhile, all the metadata, who uploaded it, when, its status, that gets logged in Postgres. And finally, the finished proposal gets saved right back to S3. And to close the loop, the user sees this final output just appear right there in the web app. And throughout that entire process, they've been getting live status updates thanks to that WebSocket API we mentioned earlier. The system is constantly talking back to them. So the huge takeaway here is how this architecture masterfully combines all these specialized serverless components into a single seamless workflow. It takes the task that once required hours and hours of skilled human work and just orchestrates it perfectly from start to finish. And this all leaves us with a really fascinating question to chew on. We've just seen how AI can build a proposal. But what happens when this exact same technology is used to deconstruct and analyze contracts on the other side of the table? What does that mean for the future of business, of law, of complex agreements? It's pretty wild to think about.